Alright guys, so let's have a look at the properties of an element, compound, and mixtures. So let's see what happens when we have to compare all these. So we'll start with some vocabulary. Now over here we have some that you should already know. For example, an element is something when it's made up of one type of atom. A compound is multiple types of atoms. Now remember, a mixture is, so they're chemically bonded, and a mixture is varying composition. So an element is the simplest of the pure substances. There's only one element in there, and it can't be decomposed. It can be defined by a fixed and unique set of properties. In other words, the properties of helium don't change. They are what helium's properties are, and there is no other element with the same properties. So a compound is also a pure substance, but it's a bit more complex, and it's made up of two or more different substances, different elements, shall we say. There are fixed compositions / ratios, and this will make sense when we talk about ionic bonding later on, and can be decomposed into their elemental components. So that's nice and straightforward. They also have a fixed and unique set of properties. Mixtures, on the other hand, are impure substances. So they can have varied properties, varied mixtures, depends on what the composition of it is. So they can vary composition as well. And they can be separated with physical techniques, whereas compounds can only be separated by chemical techniques. There are homogeneous mixtures, in which the particles are distributed evenly throughout or uniformly. In other words, it looks like it's one thing. And then we have heterogeneous mixtures, which the particles are spread all over the place. Like it's non-uniform distribution of particles. So we can sort of, you'll have different properties in different parts of the mixture. So basically, the properties of compounds are different to the properties of their component elements or the constituent elements. So each compound has unique properties that aren't shared with other pure substances. Now, basically, here we just have a couple of comparisons. For example, we have copper, oxygen, these are elements. Copper 1 oxide, which is an ionic compound, and copper 2 oxide, which is a different ionic compound. The color, alright, copper is salmon pink, oxygen's a colorless gas. Copper 1 oxide is red, whereas copper 2 oxide is black. At 25 degrees, your copper is a solid, as is your copper 1 oxide, copper 2 oxide, but your oxygen is a gas. Your density is about 9.0 grams per centimeter cubed for copper. Copper oxide is about 6.0 and zinc is about 6.4, but at 1.3 times 10 to the minus 3 grams per centimeter cubed, oxygen is not dense at all, and this is because it's a gas. The melting point, okay, copper melts at 1,000 degrees-ish, whereas copper 2 oxide is at about 1,200 degrees, and copper 2 oxide is about 1,300 degrees, whereas oxygen is at about minus 219 degrees Celsius. So I hope that all made sense. We now understand that compounds have different properties to their elements and so forth. Yeah, if you have any questions, feel free to ask them in the comments below. We'll get back to you as soon as we can. Thanks for watching. See you next time. Bye now.